Hello everyone, this is Kevin from his YouTube channel. We're going to be exploring the Pythagorean Theorem and how Mr. James Garfield proved it. So basically, as you can see from these triangles, these marks are congruent marks. Congruent simply means that these sides right here are the same length. So basically, the more marks, they're talking about a different side. So this has 2, meaning that this has 2. They're talking about these 2, and these 2, and these 2. This angle mark simply means that these angles, these 3 right here, equal 90. And therefore, what that means is on the protractor, if you measure up 90 and you find the number 90 on the protractor, if you measure the angle, it looks like a straightforward L, the letter L, as you can see here, here, and here. This helps with the Pythagorean theorem, because basically what the Pythagorean theorem is that a squared plus b squared equals c squared. Basically meaning that we're trying to figure out what these sides equal from two other sides. These sides, as you can see, are all labeled and ready to go, so we're going to explore the proof and find out how James Garfield proved it. In this picture, they have given us the measure of the angles and which sides are congruent, as you can see. Before I get into this, I'm going to explain how 90-degree angles affect everything. So, these two angles, angle GAD, this is what is called GAD, and angle GDA are the two complementary angles. Complementary simply means that these two add up to be 90. Why? Because a known rule in geometry is that the 3 interior angles, as shown here, add up to be 180 degrees, which is basically a straight line. Since they have already given us that this equals 90 degrees, we have to figure out what these two equal. Simply put, it's x plus y equals 90 degrees. Add 90 plus 90 equals 180. So therefore it makes sense. Now we can move on to the proof. The first statement states all of the given information, and then we simply have to figure out a formula that covers the area of this whole trapezoid. There are two possible ways of doing this. The first way is to find the angle of the whole trapezoid itself. If you remember correctly, the formula for an area of a trapezoid is height times base 1 plus base 2 over 2, or height times the average of the bases. The bases of a trapezoid, which is the name of this whole quadrilateral, are A and B, as shown here. They are the top and the bottom. The height is this long thing right here. So now that we know that, we can start formulating the formula. We're going to say that A plus B, which is this side, which is the height, as you can remember, is the first half of the formula. Next, we multiply it by the half of A plus B. A plus B is this. It's the two bases. Add them together and divide it by 2. That is the average of the two bases. We multiply those two together and we get the area of this whole thing. But we want more information, so we're going to set it equal to the combination of the areas of all these triangles. If you also remember correctly, the area of a triangle is 1/2 base times height. This is the base and this is the height. So it's these two times, each time, multiply them together and then multiply it by 1/2. So this is 2 times 1/2 AB. AB as shown right here. Why is it times 2 though? Because these two triangles are congruent, meaning that they have the same lengths and the same angles. So basically they're two same things. So we just combine them together to make it times 2. Next, we add plus 1/2 c squared. This is because it's the area of this big triangle. This c times 1/2. 1/2 c squared. Now that we got the equation, we can expand it and find out what James Garfield found out. The first step, as shown above, is to write out the equation. This is the equation as shown. We first combine the like terms, which are these two. 2 times 1/2 is 1, so we get the first part and the second part. AB is the only thing that changed. Now, we combine AB, A plus B, and A plus B. Since these two are the same thing, we can just say that it is squared and then times 1/2. Okay, so 1/2 A plus B squared equals AB plus 1/2 C. We multiply both sides by 2 because these fractions will make the equation look ugly. And we don't want anything ugly, do we? No. So we're just going to multiply both sides by 2. It will get rid of the fractions as shown. And we will get A plus B squared equals 2AB plus C squared. Now, if you are familiar with the method of FOILing, we will basically say it's these two times each other, and we have to distribute the A and the B to the second part, which is this part. We multiply them together, so A times A is A squared, A times B is AB, then we have B times A is AB, and B times B is B squared. And then we write the rest of the formula. These two are common or like terms, meaning that they are the same. So since they're the same, we can add them together. We get A squared plus 2AB plus B squared equals 2AB plus C squared. If you don't know how we got the 2B from here, we got it from multiplying the 2 by to the AB. So just to keep track. We have another common or like term. We can subtract minus 2AB from both sides, and we would get, guess what? The Pythagorean Theorem. This proves the right triangles above and the formula itself. I cannot believe that our 20th president, James Garfield, figured this out on his own. So kudos to him. Again, thank you for watching. This has been a pleasure to work and play the video. So please enjoy yourself and continue learning more geometry. I will see you guys next time.